I was working on an outlet that was damaged recently, and I had to shut off the breaker to a circuit that has 2 battery backups on it. It's one of those moments where you know I've got so many minutes with some safety margin that I can work on this outlet, get this thing done, and be able to plug, get the power back on before the battery backup's battery goes dead. This is probably the least expensive, if not one of the least expensive battery backups from APC, and it has a alert when it goes to below 10% of its capacity or some amount of runtime remaining, a very little runtime remaining. And I figured if I heard a beep, I would go and turn the circuit breaker back on. Why am I saying all this? Because none of that happened. Within about 10 minutes, both of them shut off. And I have a bunch of Raspberry Pis 4s and a server and a bunch of, they're all low-powered things. It should have lasted about 45 minutes, and it actually lasted about 10. I started looking into the battery, and these things were so inexpensive that I wanted to make this video because I think perhaps many people would look at this and go, well, this is disposable. To keep this thing for about 3 to 5 years, and then you just throw it out. And unfortunately, that's kind of how these companies like APC make these really inexpensive ones appear. I think it's something to help highlight the fact that if you're comfortable around electronics and you make sure you unplug stuff, and especially be safe around a battery backup like this because it is generating high voltage internally, that you can fix this stuff yourself and you can get more life out of these things without having to make this into e-waste and go buy a new battery backup. This one ended up lasting me just under 3 years. This one actually has a 3-year warranty, which is nice, but it has a 2-year battery warranty. So I was just outside the battery warranty and just inside the regular warranty, which it's not defective, so I'm not going to get a new one for that purpose. The first part of this video is going to be replacing the battery, and the second video will be taking it apart. Let's get started with opening this thing up and working on the battery. This one, unlike many of the other battery backups that I've had in the past, and I've had way more expensive APC battery backups, has a pretty simple configuration. This one doesn't have like a battery caddy that you can slide open or anything like that. This is the backup's BE425M, and I'm pretty sure many of the ones that are kind of in this range, I think there's like 4, kind of all function in this way. The first thing you want to do is make sure that you de-energize this thing, because this may seem obvious, but if I turn this thing on while it's unplugged, it powers itself on, and after a brief period of time, it's going to generate AC voltage, 116 volts, and probably with a pretty decent amount of ripple. It's pretty pulsy because it's not pure sine wave. This is a modified, and you can see how jumpy that is, a modified sine wave, which I'll get to when we start talking about the teardown of it. But it's generating voltage. This is not voltage relative to Earth, so it's harder to get electrocuted by this unless you touch between the AC probe and, like if I were to grab this, wouldn't be pleasant, but it's not Earth reference. And I'll show you by not putting my finger on it, but plugging something into the wall. So this is just floating right now. This is not plugged in at all. And I'm going to take this line, this is the line, to Earth, and I'm getting 15 volts AC. There's not 120 volts going between line and Earth. Still don't want to touch this because it's not, if there was a way for this to find, let's say this cord found a way back to Earth, it may not feel good, but it's not 120 volts to Earth. So let's flip it over and start taking this thing apart. I'll get the voltmeter out of the way. First thing you want to do is remove the battery connector. And we'll just kind of lever this out. And then this particular model has like a shipping retainer. Doesn't really want to sit. Oh, it has a little notch. That's why it wasn't wanting to fit before. There's 4 Phillips head screws that hold this thing together. This particular one, it's important to note, is the input is rated to a maximum of 7 amps. So if you buy one of these things and you're going to put on a 15 amp circuit and load it down to 15 amps, it will pop its little circuit breaker, which it has on this side. Right here, there's a little circuit breaker button, which will pop somewhere above 7 amps. And its battery backup outlets are, total outlet current is 6 amps. I think it trips at 7, perhaps for the derating for over current. but the output for the battery backup outlets is 120 volts AC asterisk 50 to 60 hertz. I think you have to select that. I think that's probably based on region. I don't think you can just press a button and change it. But it's 425 VA or 255 watts. So you pull this off. There's a lot of things wired to this back cover, so be careful not to pull it straight up because there's a whole bunch of goodies wired to it. And there are 4 really long pillars, or whatever these things would be called. Get that screw out. That slide all the way down and then connect to the other side, the top side, just to screw the whole thing together. Here's the battery. Here's the main circuit board. This is the only circuit board in here, and there's a whole bunch of stuff down there, so this should be pretty much fully discharged. So I'll pull this battery out. You pull it straight up. It's not held down by anything, except, I mean, it's held down by something. It's held down by this little cavity, and there's another little cavity on the other side to hold it in place. So this is a 12 volt 4.5 amp hour battery, and I'm going to be replacing it with a 12 volt 5 amp hour battery that apparently is used in like some kind of scooters. I'm not familiar with this. I'm not familiar with lead acid batteries this small, except that when I was doing some work troubleshooting and replacing batteries for emergency lighting, but they're actually bigger than this. Some emergency lights have smaller batteries like this size. But I'm just going to grab this and pull backwards on them. Might take a little bit of effort to get it to actually release because they're clipped in there pretty well. And I'm probably going to use a pair of pliers to pull that off. Just going to gently grab. I prefer not to damage the heat shrink, but I'm actually going to wrap them in electrical tape when I'm done. But I'm just going to rock back, and you can see already it's sliding backwards off the tab. Repeat the same thing, just grab it from either side and wiggle back and forth, and eventually it'll loosen a little bit and then slide backwards off the tab. And there you go, it's disconnected. So this is the old battery. This is a LEAC. And like I said, this one lasted just under 3 years with actually quite a few power interruptions, shorter power interruptions. So it did a good job. I mean, it lasted over 2 years, but I would have hoped to gotten maybe, I would have liked to have gotten 3 or 4 years out of it, but it lasted 3 years. So that's the old one. Here's the new battery, and yes, I have blue taped over the name of the company and model number. Basically what you need to get is some sort of battery that is a replacement to this battery. So there's plenty of places where you can get these batteries from. You can get these LEAC batteries, I think that's how it's pronounced, on a variety of places. eBay, Amazon, other batteries like Battery Plus. And I got this one from Amazon because it was part of a 2-pack, and I have 2 backup batteries. And so I thought it was a good deal because the price was about 28 bucks or 30 bucks for 2 of them. And they advertise it as having the F2 tabs, I guess they're called. And they shipped with tabs that do not match the tabs that are on this battery backup. Make sure the tabs are the right dimensions. And in this, even in the case that if they're not, don't try to connect the tabs that might fit, because you can probably grab this and get it to kind of like fit on there, and it'll see it's on there. Great. There'll be a voltage drop across this, and it can heat up this connector and can potentially be a fire hazard. So you want to get the right size connector for these things. The good thing about a battery backup, just for the sake of completeness, even if this is not appropriately sized, and for these smaller battery backups, and this were to heat up, let's say you load it down to like 225 watts and it's drawing the maximum amount of current from this battery, which is about 15 to 16 amps, maybe even more than that. And if this is dipping down to like into the 10 volt range, that current's going to go even higher to try to push out that 225 watts. So this could heat up, but the thing is that the hotter it's getting, the quicker this battery gets depleted, and the whole thing just kind of is going to shut down and kind of inherently not overheat. But if it's in a series where it's, you know, being interrupted and then coming back online, offline, could be a problem. The short of it is get the right terminals for the right connections. So that's what I did. When I found out this thing came with the wrong terminals, and then the company told me that it was the right ones that they had claimed on their website, but then they offered to send me these F2 terminals, adapters, F1 to F2 adapters, which I didn't know existed. And these are not particularly great, because when you fit these on, they wiggle. They wiggle quite a bit. They are not secure on there by any means. And if I plug this into it then, there are two interfaces now, here and the adapter, and then here to the connector. So this is just ridiculous. Try to get the battery with the right terminal on it. If you don't, then I would suggest you do the following if you happen to have gotten one from a manufacturer that kind of played this game with you. We can solder these down, but you got to be careful when you solder because it's a battery and the battery doesn't like heat. So here's the soldering iron. I'm going to stay on this side. I'm going to actually flip this around. So I'm on this side, heat source here, and solder being fed in this way. Just to minimize the amount of heating on this side of the actual battery terminal side. So first thing, let's just make sure our tabs are all lined up. I would make sure you do it with the crimped edges facing up so that you get something to solder to. Otherwise, if this flipped around, it's going to be harder to feed solder in. Looks good. And I'll hold the iron here and then just flood some solder. It's going to be a lot of solder. So let me just back this up. I wish I had heavier gauge solder for this, but it's just going to be doing this and then letting it flow back a little bit. Just one more time. Flow back. There we go. That's pretty hot. Cool that off pretty quickly. And what you can do too is use like a pliers or something and just to help heat sink it. After you're done, it'll help get the temperature back down pretty quickly. Now it's back to being cool again. The battery should be fine. We'll repeat the same thing here again. Gonna just careful not to bridge the two. In fact, do I have my little caps? Oh, there's the cap. Yeah. Make sure you always got your positive terminal capped, but in this case, one of the terminals that needs to be capped. I'm just gonna, just because I'm filming this, I will just do that as well, just to keep it from being touched accidentally by the soldering iron and bridging this out, because that will damage the battery and cause a nice big arc. That would look great on video, but I'm not gonna do that because I want to use these batteries. All right, same thing. Pressing the soldering iron in, give it a second, and then just flood it with some solder. And I gotta get a longer, heavier gauge again of solder would be really helpful here in the very few times that I need that. And we're gonna hit it again with the solder, and then bring it over. Do that again, bring it over. We'll get the pliers onto the terminal to help aid in cooling this off as quickly as possible. Now both these are on, and if I grab them, they're like not going anywhere. They're nice and secure. So they're just mechanically connected to the battery. Much better for the longevity of this and for the longevity of this whole system. When this battery needs to be replaced in a couple of years, you know, I don't care about the tabs being on there. I'll just buy some that has the proper tabs on it from a battery vendor that actually ships what they say they're selling. And then we're good to go. Now that this is completed, I think what I'll do before we finish all this up is get that electrical tape out, because it's easier to do this before than after trying to assemble everything, because you really are in a confined space with this and it becomes quite a challenge. So we'll get the tape out. So I slid it underneath, pull this around, and then just wrap the electrical tape around there. And it only really needs to be done one complete turn, and then I just kind of press it down onto the battery. This is just so you don't expose more metal to the inside of this thing than is necessary, because this was sleeved and kind of came all the way up to here, and you really only had, you know, the back part of this terminal exposed and the back part of this terminal exposed. Because the whole board is exposed on the inside, you just want to minimize exposure to anything metallic on the inside as best as possible. This just pops back on, and our black will pop back on as well. They seem a little loose, so I'm going to put the battery back down again. I feel like these terminals they gave me are suboptimal. Not bad, but then they'll do the job, but they are suboptimal. But I'm grabbing it and kind of just squishing this to kind of make sure that it's got good contact on the terminal. And if I grab it again, it should, yeah, they're not moving around as much as they were before. It's still kind of sliding around a bit. Yeah, these really don't. If that happens, what I'll do is I'll grab this thing and squeeze it and compress it down a little bit more, and then I'll press. I think these blades are actually a shallower. I think they are. I'm looking at these, and it looks like it's thicker than what this is. So the original battery, the tab thickness was 1 millimeter. This one that they shipped me, which is the adapter, 0.81. So yeah, 20% thinner. Is it kind of crappy? Yeah. You're going to get more of a voltage drop across these. They're going to get warmer, but this is a pretty sizable area to carry 20 amps for these small batteries. For this small battery backup, for I think the full rating of this at 225 watts, it'll run for 1 minute to maybe 2 minutes, and it's going to be done. Because this is a 60 watt hour battery, right? 12 volts at 5 amps is 60 watt hours. It can't hold a high sustained load for that long of a period of time. This will run longer with lower sustained loads, like say the loading on this thing, basically with all the stuff plugged into it, which seems like it was a lot when I was describing it at the beginning of the video, is maybe 40 to 50 watts. I think its runtime is somewhere in the vicinity of maybe like 20 minutes. When many of the things are sleeping, which are most of the time they're sleeping, and they were when I described at the beginning of the video, somewhere around 10 to 12 watts. So this should have went like 45 minutes before it cut out, which you think it would go longer because it's a 60 watt hour battery, but it's pretty lossy because it's a battery backup that's switching pretty noisily. Okay, what to do when these are not quite the right thickness is just crimp this down a little bit more. If you happen to close it up a little too much, get a real thin blade in there and just kind of twist. Open that back up a little bit. That should be enough to get us back on there. Let's see. It's almost there. You want it to be not easy to get on there. Like you want to have to put some pressure into getting the thing to click in. There it goes. Now it's clicked in. That's how it should fit. Firm fitting, and it's not wiggling itself back off again once it's on there. So that's great. This is the example of the one that is not the best, which is you can just wiggle this thing around and you can pull on a little bit and it pops right off. You don't want that happening because you don't want it popping off when you're putting it back in here or being really loose when it's back in here because you're going to get a massive voltage drop, blah, 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 all the things I was saying before. And sorry if that was out of focus because I've been going back and forth and this is a very large thing I'm trying to show, and it's a lot of different heights that I'm working at. So this one I've gotten on there, I'm pushing this and you can see how much more snugly that connects and fits on there. And as I'm trying to move it around, you can see the whole tab moving. So that's a good fit. And I'll just wrap this around this heat shrink. Just to, I know that I chewed it up a little bit with the pliers. Let's put this battery back in and turn it on and test it. What does that come out of the bottom? Did I damage the battery? I don't think that I did. I'll be right back, because that might be acid. After some investigation, I don't really know what's going on here. This does not look like acid. Well, first of all, the bottom of this battery is just scratched up like crazy. So I'm pretty sure this is not a new battery. This is the old battery. And it barely has any markings on it. You can see that. Yeah. This thing is scratched up like crazy. So I'm pretty sure what I got was a refurbished battery, which is fine for the price. I've seen leaking acid batteries. I'm not sure if this is like glue that was sealing up some kind of plug or something. There's these little, they look like they're plugs, but maybe it's just a dimple in the plastic, or actually it looks like it was flooded in or it came in from this side. I can't show you the other battery because that one's in the other battery backup and I do not feel like opening it up right now. I don't feel like this has anything to do with what we just did with soldering those terminals on, but I would recommend these batteries over the batteries that I got. Yeah, it looks like it's glue. If they plug something up with this. So we're gonna go select voltage DC. I'm just gonna check the battery real quick to make sure that it's not completely damaged, and I'm gonna put it back together and then not have it work at all. Let's check just voltage DC on the battery. 12.72, that sounds good. Let's put it under charge. While this thing's opened up, oh wait, the battery's not enabled. So I'm going to, just before I power everything up, I'm just flipping this back over, putting this plug back in. So the battery is back in circuit. And then I'll turn it on. It's not really going to do anything. It's going to warn me that there's a building wiring fault because there's no earth ground. So this whole thing is floating right now, so we want to be kind of careful what we're touching. But it's two floating things. It's this thing floating and the battery, so we're all right. When power was on, okay, it's beeping, the big relay's coming on, it's doing its check. It might beep and tell me that there's a problem with the building wiring. But then it's gonna start trying to charge the battery. And if I'm watching over here on my solar battery, it's showing about 9 watts going into it right now. So it's trying to charge this battery up. And let's just see how we're doing. And I have the terminals backward. So it's got 13.5 volts on the battery. And then we're going to remove power, put it in battery backup mode, and we're just going to watch this. 12.8. It just came off charge, so it's coming down quickly, but that's just because I think it's recovering. It looks as though we're in pretty good shape. I'm going to turn this back on again. You'll hear it click. And we should see the battery start charging. If we saw it fly right up to like around 14 volts, then we know the battery's hosed. But it's slowly climbing up. So the battery I think is fine. I'm going to do some more extensive testing and I'll follow up with another video. But this shouldn't matter because it's about, oh wait, is this thing powered? It is powered. Woo! I turn this off. Disconnect the battery connector. And then little wiggly dance to get, there's wires down at the bottom that you want to get kind of in between, because now remember we've got the extension for those terminals on, so the wire is set farther back away from the battery terminal, and that makes for the wires to want to push back further, which makes it more difficult to get everything down back inside there. So you kind of want to push them ahead of a little pillar down there. You'll know when you got it right when the battery just wants to sit like that, where it's flush and it's parallel to the base of the unit. And then this just goes back on top again. Push it down, snaps into place. We plug the battery connector back in. If I can get that out, put the battery connector back in. Put the 4 screws back in, and then we're good to start using it. It will take about 24 hours to fully charge. APC says 8 hours, but I would say for the first charge, when the battery's been shipped, you don't know the state of charge. So it may take a little bit longer. So generally I look for about 24 hours. So that's how you replace a battery in the APC BE425M, and it probably can apply to other APC battery backups. Some troubleshooting, some looking at some weirdness with the batteries I got, which I would not recommend if you somehow found out which batteries what manufacturer and company it came from. Look for a good battery. And I think that's it. It helps you get more life out of this thing, and you can keep replacing the battery in it over and over. If you have any questions or anything like that, leave them in the comments. And like and subscribe, and I will see you in the next one. Thanks for watching. Take care.